There is something deeply wrong with the official story of lighthouses. Not wrong in a small way. Not a minor historical footnote that got misattributed, or a date that scholars argue about. Wrong in a way that begins to unravel the moment you stop looking at lighthouses as navigation aids and start looking at them as structures, as architecture, as technology. Because when you do that, when you actually sit with what these buildings are and what they were supposedly built to do, the standard explanation stops making sense entirely. They were too tall, too thick, too expensive, too precisely engineered, too widespread, and the timing of their mass construction across the entire planet within the same narrow window of decades points to something that has no rational explanation inside the history we were taught. This video is going to walk you through what lighthouses actually appear to be, what their real function may have been, and why the people who inherited them went to considerable effort to retrofit them into something that looked more ordinary. If this is the first time you are encountering this kind of research, take a breath. Let this sit with you. You do not have to accept all of it. You just have to be willing to ask the question. If you have been following this channel for a while, you already know that the lighthouse question is one of the most compelling threads in this entire body of research. Like the video, subscribe if you have not, and let us get into it. The first thing you need to understand is the scale of lighthouse construction in the 19th century. Between roughly 1,800 and 1,900, more than 10,000 lighthouses were built across the coasts of Europe, North America, South America, Asia, Africa, and Australia. 10,000 structures in a single century. During a period when the global population was a fraction of what it is today, when labor was expensive, when materials had to be transported by horse and ship, when there were no cranes, no reinforced concrete, no diesel equipment of any kind. The official explanation is that maritime trade demanded it. Ships were running aground, cargo was being lost. Insurance underwriters and merchant guilds pressured governments to build navigational aids along dangerous coastlines. That explanation accounts for perhaps 2,000 of those structures, maybe 3,000 if you are generous with the definition of a dangerous coastline. It does not account for lighthouses built on flat, easily navigable stretches of coast with no significant shipping traffic. It does not account for lighthouses built on inland lakes and rivers, far from any ocean route. It does not account for lighthouses constructed at elevations so high that their light would have been obscured by weather almost continuously. And it does not account for the construction standards, which in many cases wildly exceeded anything that a simple light tower would have required. Look at the Eddystone Lighthouse off Plymouth, England. The third version, completed in 1759 by John Smeaton, was built from interlocking granite blocks, using a method Smeaton himself described as derived from studying the root structure of an oak tree. The blocks were shaped so that each one locked into the ones beside it and below it, creating a structure that could flex slightly under wave impact without fracturing. This is not the engineering logic of a lampstand. This is the engineering logic of a resonant structure, something designed to absorb, distribute, and transmit force rather than simply resist it. Smeaton's tower was so over-engineered for its stated purpose that when it was decommissioned in 1877 and replaced, the replacement was built not because Smeaton's tower had failed, but because the rock it stood on had begun to erode underneath it. The tower itself was still perfectly intact. It was dismantled stone by stone and re-erected on Plymouth Hoe as a monument, where it stands today. A navigational aid that outlasted its own purpose by centuries. Built to standards, no one building a lighthouse in 1759 had any practical reason to demand. Now consider the interior arrangements of lighthouses as a category. Almost universally, the standard lighthouse from the 18th and 19th century follows the same internal layout, regardless of which country built it, which architect designed it, or which coastline it occupied. A hollow cylindrical core, a staircase winding upward around the inner wall. The walls themselves extraordinarily thick, sometimes exceeding 2 meters at the base. Small windows positioned at regular intervals, not for views, but placed at specific heights with specific orientations. And at the top, a lantern room, enclosed in glass, surrounded by a gallery, set on top of a cast iron or stone pedestal that runs down through the center of the structure to the foundation. That central column is the element that does not belong in a simple lighthouse. You do not need a load-bearing central column to support a lamp. You need a floor, a mounting bracket, and a fuel supply. The column is not structural in the conventional sense. It is something else. In electrical engineering, particularly in the work emerging from the late 19th century onward, a conductive column running from ground to an elevated point, surrounded by a hollow cylindrical chamber with specific dimensional relationships between height, diameter, and wall thickness, is a recognizable configuration. It is a waveguide. It is a resonant cavity. These are components used to collect, concentrate, and transmit electromagnetic energy. This is where the connection to what researchers in this field call the Old World becomes unavoidable. The civilization that preceded the one recorded in standard history, whatever it was, whatever we choose to call it, appears to have had an advanced working knowledge of electromagnetic phenomena. The evidence for this is scattered across architectural sites on every continent. The dimensions of the Great Pyramid at Giza, when analyzed with modern understanding of resonant cavities and frequency relationships, produce results that are not coincidental. The placement of megalithic sites along geometric lines that correspond to the Earth's electromagnetic grid is not coincidental. The consistent use of specific stone materials, granite being the most common, a piezoelectric material that generates electrical charge under mechanical stress, is not coincidental. The lighthouses fit this pattern precisely. They are built primarily from granite or from stone with high silica content. They are positioned along coastlines, which are zones of continuous mechanical energy, wave action, tidal movement, pressure differentials. They are tall, narrow structures with specific aspect ratios. They terminate in a point or a dome. They contain a central column. They have small apertures positioned at calculated heights. Every single one of these design choices corresponds to a functional requirement if you assume the structure is designed to interact with electromagnetic fields, to collect atmospheric electrical energy, to resonate at specific frequencies, and to broadcast that energy outward. This is not a new idea in the alternative research community. Researchers have been drawing comparisons between lighthouse architecture and Tesla's Wardenclyffe Tower for over a decade. Tesla's tower, the one he built at Shoreham on Long Island beginning in 1901, was designed to transmit electrical power wirelessly through the Earth and through the atmosphere. It consisted of a tall wooden structure, a central shaft, and a large copper dome at the top designed to ionize the surrounding air and create a conductive pathway for energy transfer. Tesla called it a magnifying transmitter. The resemblance to lighthouse architecture is not superficial, it is structural. The same logic of elevation, the same logic of a central column reaching to an elevated terminal point, the same logic of a dome or lens structure at the top to manage the electromagnetic field boundary. The lighthouse lens itself, the Fresnel lens that became standard after Augustin Jean Fresnel's work in the 1820s, is an extraordinarily sophisticated optical component. It concentrates light into a beam with almost no energy loss. But a Fresnel lens also functions as a focusing element for electromagnetic radiation beyond visible light. In the right configuration, it could focus or shape a broadcast beam of energy as easily as it focuses a beam of visible light. The timing of Fresnel lens adoption across lighthouses worldwide is interesting. It accelerated dramatically in the 1830s and 1840s, precisely the decades when official history places the beginning of serious experimental work in electromagnetism by figures like Faraday and Ampere. The official explanation is that Fresnel's optical genius simply improved lighthouse efficiency. But consider an alternative reading. The people who had inherited these structures and were attempting to understand their original function were experimenting with optical and electromagnetic focusing components, and the lighthouse network was their laboratory. Because here is what the record shows happened in the late 19th century. One by one, lighthouse authorities across Europe and North America undertook what they described as modernization programs. The original lamp assemblies were removed. The original lens configurations were altered. New lantern rooms were installed. And critically, electrical wiring was introduced, not to power the lighthouses from an external source, which would have been simple, but threading through the existing structure in ways that were often described by contemporary engineers as unnecessarily complex. There are documented cases of lighthouse engineers in the 1880s and 1890s expressing confusion about the internal arrangements they encountered when attempting to install electrical systems. The walls contained channels and shafts that had no obvious purpose for a simple light installation. The stone was cut in ways that suggested pre-planned routing for something, but the original function was unclear. These observations appear in engineering reports that are publicly accessible in National Archive collections. They were noted as oddities, and then the work continued. The channels were filled, the shafts were sealed or repurposed for electrical conduit, and the modernization was completed. What was removed in that process? What was altered? And who directed the alterations? The lighthouse authorities of the 19th century were not independent bodies. In Britain, Trinity House controlled the lighthouse network and reported directly to the Crown. In France, the Administration des Phares et Balises operated under the Ministry of Public Works. In the United States, the Lighthouse Board was a federal body with military representation. These were centralized, government-controlled institutions with significant power over what information entered and left the public record regarding these structures. The same period saw the suppression of Tesla's wireless energy work. J.P. Morgan withdrew funding from Wardenclyffe in 1903 once it became clear the system could not be metered and sold in units. Free energy, energy that could be broadcast through the atmosphere and collected by anyone with the right receiver, was commercially and politically incompatible with the emerging energy economy being built around coal, oil, and centralized electrical generation. If the lighthouse network was a functional system for distributing atmospheric electrical energy, its alteration and effective deactivation in the 1880s and 1890s would have represented the final step in a longer process of concealment that began with the mud flood events, the reset of civilization that buried the previous world and left its structures available for reappropriation. The new administrators did not necessarily know what they had inherited. Many of them simply did what made sense given the tools and knowledge available to them. They saw a tall stone tower with a room at the top, and they put a lamp in it. But the structures themselves were not built for that purpose, and the engineering record, when you read it carefully, shows that the people who tried to retrofit them often knew they were working around something they did not fully understand. There are approximately 400 lighthouses worldwide that have been decommissioned but not demolished. They sit empty on their coastlines, the lantern rooms dark, the original interiors largely intact beneath decades of weathering and neglect. If the hypothesis explored in this video is correct, and these structures are the surviving nodes of a planetary energy distribution network built by a civilization that understood electromagnetic physics at a level we are only now beginning to recover, then what sits in those 400 towers is not a historical curiosity. It is infrastructure. It is infrastructure that was built to last, engineered with materials and methods specifically chosen for longevity, and it is waiting. The question that follows from all of this is not whether the official history of lighthouses is incomplete. At this point, that case is straightforward to make. The question is what you do with that understanding. You start looking. You look at the structures in your own region, wherever you are in the world. You look at their placement, their dimensions, their construction materials, the official timeline of when they were built and when they were modified, and what the stated reasons were for each modification. You look at what was removed and what was installed in its place. And you ask why a civilization in the grip of industrial poverty and labor scarcity built these things with the precision and durability of temples, when a simple wooden post with a lantern would have served the stated purpose just as well. The answer to that question will not be comfortable, but it will be accurate. And accurate is where this research begins. There is a lighthouse on the coast of Wales called the South Stack Lighthouse, built in 1809 on a small island of rock connected to the mainland by a suspension bridge. The bridge itself, a rope and iron construction original to the site, had to be replaced multiple times over the centuries. The lighthouse has not. The original 1,809 masonry stands today in near-perfect condition. The official explanation is good construction. The actual explanation may be something more specific than that. The stone used at South Stack contains significant quartz deposits. Quartz is piezoelectric. It generates a measurable electrical charge under mechanical compression. A lighthouse built of quartz-bearing stone on a rock platform that receives continuous wave impact, mechanical compression delivered without pause across 2 centuries, would have been generating a consistent low-level electrical field inside its walls for 200 years. That field does not rust, it does not corrode, it does not fatigue. It may, in ways we do not yet have instruments sensitive enough to fully document, actively preserve the material it inhabits. That is a different kind of lighthouse than the one in your history book, and it is a more interesting one, not because it makes a better story, but because it is a more honest description of what the evidence actually suggests when you refuse to stop looking. Do not stop looking.